say this, that any corrections have to be done before next Wednesday or by the break. Because if you wait till after the break, you'll do worse.
When do we do that?
That's next Wednesday.
When do we do it? Like after school?
Anytime before school or after school. Really? Today's fine. What? What? Well, Friday's just bad after school because nobody wants to still be here at 3 o'clock. Well, if it's... Well, you gotta... Is it during that 45 minutes or is it truly after school? Do you know what I'm saying? Because, you know, we have that 45 minutes at the end of the day now. If it's during that 45 minutes, then B-Day is best. Because I use the A-Day for my online kids. But if it's truly after school, like at 2:30, then it's any day. Except Friday, because nobody wants to be here at Friday at 3 o'clock, do they? Exactly. Alrighty, so questions on 3-1 for starters. So it is 10-8 today. I guess.
Like when you simplify like fractions that have like they have like exponents in the top and exponents in the bottom, and you have to add them. I don't
Except
know.
you subtract them.
Yeah, and subtract them. I don't know how that works.
So look, if I have x to the 8th, y to the 7th, over x to the 4th, y to the 9th, right? As long as I have the same base, I just subtract these.
Top to bottom.
No, subtract the exponents. Yes, you're going to go 8 minus 4, and you're going to go 7 minus 9, right? So if I do that, this one would give me x to the 4th, right? And that one would give me y to the negative 2. But I never want to leave that negative like that, so that negative tells me to move it where? Into the denominator. I would have gotten x to the 4th over y to the 2nd. Now what most kids do, and what I was taught to do when I was in high school, was this. You just 4 of those, get rid of 4 of those. 7 of those, get rid of 7 of those, and you end up with x to the 4th over y to the 2nd.
What about with numbers in front of it?
That doesn't matter. The numbers just do their own thing. The numbers don't impact the variables or their exponents.
It's like it's 12 over 4 is 3.
What?
It's like 12 over 4. Is it 3?
Yeah, it's 3.
8.
No, it's 3. Because 12 divided by 4, right?
Okay.
Because 12 is 4 times 3, and then those 4s reduce out, right? Okay. So nobody has any questions on 3-1? Yo, Hadley. 25. Ah, 25 is a good one. So 25 says mz minus 5mh squared minus 5nz plus 25nh squared. Like that?
Yeah.
Okay, so we're going to group the first two and the last two, making sure I get that sign, right? So what will come out of the first two? An m, right? Whenever I take the whole thing out, what has to be left? So I got 1 minus what? 5h squared. What comes out of the second ones? A negative 5 n.
It's MC. It's MC minus 5MH.
You can't take an nz out.
I know, but
No, inside the, at the very beginning, the problem is MC.
Oh, there's a z right there. So that is z minus 5h, isn't it? Yeah, I didn't see that. So it's z minus 5h. So then this is going to give me z minus 5h squared again, right? These now match, right? They come out front, so we got z minus 5h squared. And then what's left? M minus 5n, right?
is it okay if you wrote it? I mean, if you flipped one?
Doesn't, yeah.
Okay.
This and this
Like,
are what? They're the exact same thing. Why? Multiplication is commutative. The commutative property of multiplication. Okay? They are technically the exact same thing. Okay? Hadley, does that answer your question?
Yep.
Okay. Anybody else?
What about number 22?
Number 22. So I got 12x cubed minus 3x squared plus 4x minus 3, right? So I'm there, and there. Well, what come out of the first two?
3x squared.
3x squared, and I'm left with
4x minus
4x minus 3, right? Now, what you're doing is you're saying, well, I can't take anything out, right? But I can take a plus 1 out, because 1 times that is the same thing, right? Now this looks the exact same. I take them out, I get 4x minus 3, and I'm left over with 3x squared plus 1. Does that make sense? Whoever asked that? Smedley, you were next.
Yeah. I'm just confused. Like, what if it doesn't work?
It does.
Well, like every time.
For this, it does. Remember how I said the way they wrote these made them conducive to this? Yeah. The way they write this kind of problem makes them work out.
So okay.
They're going to work. I mean, I guess you could have one that's prime, but they're going to
If
work.
it didn't work, what would you say? Is it
Say it's prime. I mean, sometimes you'll have it to where you might have to flop 2 terms to make it work, but I don't think they even put any of them on there. I think they all just work the way they're written.
Okay.
Yeah. Peterson.
I'm confused on how you got 3x squared in the answer.
Well, because I took a 3x squared out of that term and that term, right?
Well, I know, but when it, like, how did it get down there? It's
Well, because when I factored these two out, I took them out front. What's left? Aren't I left with 3x squared plus 1?
That should be 9x.
yeah, it should be a 9x squared at the first.
Oh, yeah, I wrote that down wrong. That's a 9, not a 3.
No, it's not.
Just a,
No?
Yeah.
Yeah, it is.
Oh, up top, yeah.
Yeah.
I thought you were talking about like the answer.
So when I take that 3x squared out, right? When we factor, what are we doing? Dividing, right? So 12x cubed divided by 3x squared. 12 over 3 is 4. X cubed over x squared is x, right? 9x squared divided by that. 9 divided by 3 is 3. X squared divided by x squared is 1. 3 times 1 is whatever. Yeah. And then this one, I just take a positive 1 out, which leaves me with the same stuff. Now they match, right? Once they match, they come out front, and I just write down what's left over.
Oh.
Well, once they're gone, that's left over.
Okay, I just didn't get that part of the lesson yesterday, I guess. Because I was just putting, like, the middle, what you have there, like 3x squared times. I just kept putting that as my answer.
Gotcha.
So, okay, that makes more sense now.
Okay. Yo.
So when you're seeing what can come out of the first set of parentheses,
Yes.
can you take out the negative sign with it and then have it?
Only if the negative's out in front. Yeah, because if I take that negative out, that's going to make that a negative now.
Can you just make it then be negative 3x squared minus 4x plus 3?
You could if you needed to, yeah.
That
It would still work.
it would change.
It would just be more work.
Okay.
Yo.
On 26, like the things I pulled out in the parentheses, they like canceled out, so it was 4y plus 3, and then the other one was negative 4y minus 3.
No, it's because you didn't take the negative out, remember? Anytime you have a negative right there, that sucker's coming out. Every time.
Okay.
Anytime. So when you took out, whatever you took out of the back, was it 25?
Yeah.
Needs to be a negative 25.
Okay.
Then it makes it work. And again, that goes back to what was said over here somewhere. That's the way these problems are written. That's just the way they work. Okay, which kind of sucks because... But that's the way they write them.
Kinda nice
Okay.
though, 'cause then it
Well, it does. You're right, it is. But all of a sudden now they do something one little bit different. And you're like, wait a minute. All right, so that's enough of that. So, 3.2. So it is still 10-8. And this is SM2H, Unit 3.2. This is fourth period, and our objective is going to be able to Okay, listen up. Now, we're going to continue doing the exact same thing we just did. Okay? We're going to factor. Now, we're going to factor specific forms. So like right now, today, we're going to factor polynomials that look like this. But in every one of these, A is going to be a 1. Okay?
A equals
Wait, then why don't you just write one?
Because you do.
Well, because we're going to use the same equation next time, except now it's going to be when A does not equal 1. And then it's a little different animal. Does that make sense? So for right now, everything's going to look like this. Now, with that being said, I don't know why number 21's on this assignment.
We just crossed it out though.
So I would skip 21. I mean, you can try it, but yeah, I'm not going to teach you how to do it today. Not hard, just different. That's next time's discussion. Okay? Alrighty, so if I had x squared plus 11x plus 10, and I asked you to factor this, anybody have any idea what they're really asking you to do?
Well,
Nobody in here has ever factored before?
Yeah, we have.
You have?
Simplify.
Okay, like that. Okay, but that's usually when we had like GCFs and stuff. We're not going to have GCFs anymore.
Terms that find things.
Okay, so basically, what does it mean to factor in this sense when it looks like this? Anybody know? They're basically going to ask you to reverse what? I'm going to reverse FOIL. Okay. Now, technically it'd be lie off, but whatever.
You said that last time, but like.
Yeah, I know.
So Lloyd is the superior being.
So basically, Barker, getting this on film for your parents, you're saying that what you're saying is better than what the teacher's saying. Is that what I'm getting?
Yeah, kind of.
Because that's okay. That's all I needed to hear. Okay, and F for him. Okay. Now, this is what you do. It's really easy. You write 2 sets of parentheses. Just like we did. This is a trinomial. I'm going to turn it into 2 binomials. Right? Now, what 2 things can I multiply together and get x squared? X times x. I write an x and an x. Now, from here, there's a couple of tricks that they can teach you. I don't really subscribe to them. What I do is I simply take this positive 10. It's important you know what the sign is. And I'm going to factor that sucker. Okay? 5 and 2. Positive 5 and positive 2. Now, they have to multiply to get your C. They have to combine, add or subtract to get your B. Problem is that 5 plus 2 is 7. I need an 11. What other options are there for multiplying and getting a 10? I'm going to get a plus 10 and a plus 1. 10 times 1 is 10 plus 1 is, I write that, plus 10 plus 1, and now I have factored that sucker.
Whoa, wait.
You're welcome.
Big brain.
How does that work?
Now, oh, what? What if my 10 was negative? Alrighty, so, now, you got to understand that there are certain problems that are not factorable. So let's say that we went with Dixon's suggestion and says, well, what if I had a negative 10 there, right? Well, because this is a form where A is 1, it's still going to be what and what? Still x and x. But now I'm going to break down to negative 10. So now this is a little bit more options here. So what are my options or my factors of a negative 10?
Still has to be
Negative 10 and a positive 1.
or
A negative 1 and a positive 10.
That's it, right?
Negative 5, positive 2. Negative 2, positive 5, right? Now, can I combine these using these signs I have here and get a positive 11? I can't. So in this situation, it would be, it'd be prime. I can't factor that sucker. Now, here's what's funny, Dixon. In a few days, I'm going to teach you how to do that. The difference is that can I do it this way? No, so I'm going to give you another tool, throw in your tool bag, so when you can't factor it like this, you can still solve it. You're welcome. What was that?
This reminded me of Handy Manny when you said that.
Handy Manny? Is that like Bob the Builder?
Yeah.
Oh,
It's Walmart version Bob the Builder.
it's what?
It's Walmart version Bob the Builder.
He's like,
He talking tools that were kind of creepy.
yeah.
Talking tools? I talk to my tools sometime. Come on, baby, just tighten it up. Come on. You know,
He has a huge nose.
Why not name his tools? Dang, very good.
I got a couple of them. Yeah, I got Big Bertha.
Heavy Sandy, like, who the
Yeah, I can't look like
I could see that. My next door neighbor's company is actually named Bob the Builder. Straight up. Yeah, I'm pretty sure he did. Yeah, his name's Bob. And he's a builder. And his company name is Bob the Builder. What? I'm pretty sure they're not going to come after him. Can we, get back to what we were doing, or? Oh, okay. So, let's say I've got x squared minus, let's say I got x squared minus, okay, so x squared minus 7x minus 8. Okay? So, here we go. So, what's it going to start out with? X and x, that hasn't changed, right? And I'm going to take my negative 8 and I'm going to factor that sucker. Now, it's important to make sure you've got the sign right, because that gives you a lot of different options. Yes?
Is it always going to be x squared, or is it going to be something like, say, 24, right? And does it matter what you put? So,
24?
No, I'm saying, so, an example, if it's not x squared, say 24 subtract 7x subtract 8.
No, no. If you go back to my objective, that's actually a really good question. Now listen, you guys got to understand something. If I am, let me think of this. Let's say I need to cut a board in half, right? Am I going to go into my shop and get my drill? No, I'm going to get a what? I'm going to get a saw, right? Because I got to have the proper tool for the proper job. This is a really good question, Flinders. What you need to understand is that what I'm teaching you today is the tool you use to solve that kind of problem. If it doesn't look like that, you're going to use a different tool. Does that make sense? So yes, that's actually a really good question. Bam!
We haven't unlocked it yet.
I have not given you that tool yet. Dude, put that on. You started it. You're like, oh, I can only talk like this. Teenagers, man. Now, back at Justice League headquarters. So, what are my options here? 6 and 1?
I mean, 6 and 2. 6 and 2. Never mind. Take that back. Take that back. 4 and 2.
So I got negative 1 and 8. Negative 1 and positive 8. I got negative 8 and positive 1, right? I got negative 4 and positive 2, and I got negative 2 and positive 4, right? Now this is a skill. Listen up. This is... That was a little funny. Yeah. Go there you go. Now, what I would do is I would stop factoring when I got to the answer. But I'm trying to show you all the options here. Now, this one, even though that's the first one you said, that's not the answer. Why? That gives me a positive 7. I need a negative 7. So that's going to give me x minus 8 and x plus 1. Now, here is something that I'm going to tell you, and I guess this could be another little tool. You should never miss one of these on a test. Ever. Like, ever.
Because you can do it right now.
Because I can always do what? Foil it and check it. But I'm telling you, you guys are too lazy. You're just too lazy. What'd you say,
I
Flinders?
said not wrong.
23 years. I'm telling you right now. I've been doing this a long time.
I was saying you were right.
Like when they say
Oh, I know.
check
I'm
your
just
work.
saying. I tell you something, it's 23 years of experience talking. So, pretty sure. Tolman, am I ever wrong?
No.
Your name ain't Christy.
Yes, you're always right.
Okay. Even when I'm wrong, I'm the teacher. My name's on the wall. I'm still right. Now, that's a mistake. That's way different.
You forgot to teach
People-
us half of the assignments.
I forgot. That's different. That's way different. That was Barker again. He's pissing me off. Now, let's say I do x squared. Somebody give me a number. X squared.
7.
What? We just did 7. I like that. Okay. Minus 21x plus.
3.
10.
Shut it. See, you can't. See, now that's the difference. You can't just. Now just make numbers up now. Because it's got to work.
7.
You know what I'm saying? 7 don't work.
63.
Why does it?
No, that
112.
60.
You could do 22.
Could I?
You can do
Okay.
4. 4.
Okay, now you're learning. See how he's thinking now? That was actually pretty smart. Okay, so he actually, what'd you say?
I said.
First you said
I said 22.
22, and then you're thinking, oh, now if I go negative 22, now he's learning.
That's the one.
Yeah, but see how you're starting to see it now?
Yes.
Yeah. At least Hadley's got it. So I got negative 22. Now, if you're smart and you're starting to understand how this works, you know how to use this tool, you shouldn't have to factor this whole thing. You should factor it once, and it's going to be what?
Positive 1 and negative 20.
Positive 1 and negative 22. Why is that going to work? Because that's going to give me negative 21, x minus 22, x plus 1. Bam. Anybody besides Hadley seeing this?
I answered the
You-
problem, so I think I saw it.
You also said 6 and 2.
You also said 6 and 2.
Okay, that
So, I mean, if you want to go there, I'm just saying. See, now, Sierra, tell me this class is not worlds different than my fourth, fifth. So different. See, these kids went to lunch and all had a rock star. So see, we're all like, woo! What? Did I answered that already, didn't I?
Yes, you can.
Like we all said it was the what?
Yes. The
Community property, right? Sorry, but Peterson.
So basically, is it if the signs are different, it's prime, and if they're the same, it's not?
No. Let me show you. Okay, that's actually a really good question as well. There is no way to just look at it and say it's prime unless you go and start factoring and realize that I cannot get that combination. Yeah, there's no way to just look at it because what you're going to have is you're going to have negative, and there's 4 options here. And I used to teach you this little cheat sheet and we're like, oh, and then you're memorizing a bunch of crap that doesn't matter. If you can do this, none of that matters. So you're going to have a negative and a positive. Or a negative and negative, or a positive and positive, positive and negative. There's this little cheat sheet I could teach you and say, if it's this, it's this, if it's this. None of that matters if I can factor. If we all can't factor 22, you're in the wrong class. I mean, right? You know what I'm saying? So let's do one of those. Yeah.
But if it, like, say that was a positive 22, you can't get that to a negative.
Okay. Then it's prime, but it's not. It has nothing to do with the signs. So, like, let's say I did this. Here's a good one. Let's go x minus. So, x squared minus 9x plus 20. Different signs, right?
Yeah.
Now, let me teach you guys something. So,
Why are you grabbing this?
I was trying to figure that out myself. Do you see something here, Hadley, or what?
Yeah.
Okay, don't tell anybody because I want to prove a point here. You and me, Peterson, you ready?
Yeah.
Okay, so start factoring a positive 20.
4 and 5.
So I got a pot. Now you got to have the signs. Now why is it important to have the signs here?
So you know you're
Because it
doing.
gives you a different number.
Yes?
You know what's back.
Yeah, because that's what's going to go in here, right? Because I'm going to take that sign with me. So positive 4, positive 5. Keep going.
2, positive 10,
Positive 2, positive 10.
positive 20, positive 1. Oh, you can do like negative.
Oh! See what I did there? You just saw it, didn't you?
Yeah.
You're welcome. I'll be here all year.
Wait, what? I'm still.
-4 and
Okay.
-5.
You can do negative something.
Would you just like to come and do this now? So
She was asking, so I was explaining.
So do you see what I'm saying? So now, here's the thing. So now I got -4, -5, -2, -10, -20, -1. So now I got x minus 4, x minus 5. Booyah. You see what I'm saying? Yeah.
Done.
Hey, Charlie.
This is a different.
I said, hey, Charlie.
So I can. Or no.
I addressed you, did I not?
Oh, I was thought you were just saying hi.
Why would you stop and let
I
them
have
say,
a question.
hey?
I think it's a different tool, but could you put like x to the third and then it would turn into a trinomial? And then you can do the same process? Or is this only when it's this?
Okay, so right now, tools,
Okay.
this tool, we will do trinomials.
Alright.
This actually is, we're starting with the trinomial, but we will, what you're referring to is a cubic function. Like right now, this is always funny, because this always, does anybody know what kind of function this is? What it's called?
Unit of property.
A square.
No. Okay, now, it's a squared function, but do you know what it's called? Everybody screws this up. It's actually called a quadratic function. But people always think, well, quad is 4. It's not. Okay, quadratic is when it's squared. If my highest degree is a 2, it's a quadratic. If my highest degree is a 3, now it's a cubic. If my highest degree is a 4, now it's called a quartic. Anybody know why? Say it. 4 quarts in a gallon. Quartic. What about 5? Anybody know what a 5th degree term is? Funny. It's called a quintic function. But we won't go above a cubic. But yeah, that's yeah. Well, no, actually we do get into some, but they're special. I'll teach you how to do them. Okay. Alrighty, so should we do one more?
Yes.
Yeah? Alrighty, so let's go x squared. So you wanted it, give me a number.
27.
13.
28's a good one. 28x. Let's go.
Oh,
196.
calculator.
Thank you.
The calculator.
Calculator. Wait.
Calculator.
All I gotta do is factor 196, right? Now, what makes problems like that challenging?
We're not smart enough.
I heard it. Yeah, there's just so many different factors here. So this is where it kind of goes back to Peterson's. Dude, you need to shut that up.
No one heard that.
Okay? Now, what you're going to realize is that this becomes a skill. Because I could literally spend 10 minutes just factoring this sucker, right? Okay? So what you will learn is you say, well, I got to get to 28, right? Well, that's going to be a situation like I can't do, I don't know, what is that, 98 and 2? I mean, there's no way. You know what I'm saying? As this number gets bigger, it usually means that my terms get closer together into the middle of that number. You know what I mean? So, and then, but literally you could spend 10 minutes because you got all the positives. I could do all the negatives. I wouldn't. No, I guess you could. You know, but you'll learn it really is a skill. You say, oh, well, 28's 14 and 14. 14 times 14's 196.
Wow.
That's good math.
Do you see what I'm saying? Yeah. So literally what I did is I just divided that by 2 and squared it, and I had my answer. Yeah.
If you do it, it was like negative x squared.
Now, that's actually a good question. If I have, well, let me put it this way. If you go back to my objective, okay, it was ax squared plus bx plus c, right? We had a equals 1. This was written down in my objective, I believe, correct? Now, what is this? No. What is this? You're right, it's a trinomial. It's a quadratic, but it's a quadratic that's written in what? First thing you need to do is make sure it is in standard form. My guess is right now, Weston, everything's going to start with the positive. If it didn't, factor a -1 out and then do the rest. Because you would never, and this is something you learn down the road, you never want to leave that negative out in front like that. Factor out a -1 and treat it just as a -1 and then work on what's left. Does that make sense? Yeah. That's what I would do. Okay? I don't think they do that, but on a couple of these, they didn't write them in standard form. It's like I look at 12 and kids are like, oh, what do I do there? But then you rewrite it and it's like, oh, that looks just like all the rest. Does that make sense? Okay? Anybody else? Time is yours.
What number did you say we can't?
You can try 21, but notice 21 does not fit our objective because my A is a 4 now. That's one of those that were on there to see how smart my kids are. Well, but the 4 is going to change it a little bit.
Yeah, you change it out of a 4. You just put it 3 squared.
2x and 2x. 2
Oh.
times 2 is my 4. Okay, get busy. Let's go.
Yeah, wonderful, man.